We're about halfway through chapter 13, well, unit 13, I should say. And like I said, your test is going to be Tuesday of next week on the 9th. So we have four lessons to learn this week, 5, 6, 7, and 8. And then we will move on. A little bit of bad news though about your IB exams. Um, we should have been darn near done learning and started reviewing for the IB exam. What I'm getting at here is because I'm going to have to teach you all of the calculus this year, we're going to have very little review time. The strong suggestion would be for everybody to be hopping on Revision Village, maybe splitting some memberships or something like that, and start to review now because I am not going to have very much time. It was either that or fail everybody because you were going to fail the calculus. You know what I mean? Couldn't let that happen. So you're going to want to start reviewing now. Good. Got that out of the way. Cool. Let me find my... There we go. So we are going to be talking about the derivatives of exponential functions. The wonderful thing about IBSL math is that the only exponential that we ever work with is base E. Thank goodness. Because it's very easy. E to the x is a very special little function. The reason why, it's its own derivative. The derivative of e to the x is e to the x. Isn't that neat? It's its own derivative. So cool. So we can use the chain rule, which is what this is showing you. Basically, it's saying, hey, look, if the derivative of the exponent is anything other than 1, if the derivative of the exponent is anything other than 1, there must have been a function sitting up there. So the derivative would follow the chain rule. It's the derivative of the outside layer, so to speak, which would be the e to the x function. So you would say e to the, and don't touch its inside, basically the exponent acts as its inside, times the derivative of its exponent. Just like that. And of course you'll see that happening in the notes. Since it is its own derivative, the derivative of e to the anything is write the original function, multiply by the derivative of the exponent. There you go. So let's find the gradient function. That means let's find the derivative. The constant that's on the front of any function just comes along for the ride. And since the derivative of e to the x is e to the x, the derivative of 2e to the x is 2e to the x. At the next part, though, the derivative of any e function is write the original function and then multiply by the derivative of the exponent. And the derivative of that exponent would be -3. So it cleans up to 2e to the x minus 3e to the negative x. Negative 3x, excuse me. Just a 3. There you go.
How hard?
Okay. Now, like I've said every single unit, do not be fooled by how easy the things are when they're all separate from one another, please. You know that your depth of knowledge needs to be able to handle putting multiple concepts into one question.
I just can't wait for the news to be dropped on like the record.
So that was the chain rule. Hey, look, a product rule. A product rule. U prime v plus uv prime. That's how we're going to find our derivative here. I will define u as being x squared and v as being e to the negative x. U prime is just 2x. Drop the 2 down. Now v prime, I don't want to show the work, I just want to talk about it. It would be write the original e function, which is e to the negative x, times the derivative of its exponent. But what's the derivative of its exponent?
-1.
-1. That makes v prime negative e to the negative x.
Oh my god.
I'm intrigued.
So our derivative then I'll show the work. I'll show the work. V prime is the derivative of this, right? Your job is to write the original, and then by the chain rule, multiply by the derivative of its exponent. Okay. Yeah, no problem. So let's fill out our product rule. We have u prime v plus u v prime. It doesn't really clean up all that much, does it? There you go. That's it. C is a fraction. That means we're going to be using the quotient rule that we quote unquote learned, reviewed, brushed the dust off of on Friday. Quotient rule, let's see. U prime v minus uv prime all over v squared. I'm feeling colorful today, so I'm going to scooch over to purple, where u is e to the 2x. And v is just x. Again, I would like for you to just be able to see u prime just by thinking through it. Okay, it's e to the 2x times the derivative of its exponent, but the derivative of its exponent is 2, so it's just 2 times e to the 2x.
Okay, well.
And b prime is mad simple, it's just 1.
That one was hard.
Let's see what we get here. U prime v, so 2e to the 2x times x, minus uv prime, e to the 2x times 1. That makes life very easy. All over v squared. There's really not much to clean up, to be honest with you. It's really just drop the parentheses. I'm going to move this x to between the 2 and the e just because it feels better. 2x e to the 2x minus e to the 2x over x squared. There's really not much to it.
It looks so cute. What? This one looks cute. This are cute.
Wait. Yeah. You good?
Oh, that's pretty fast.
Put your mask on, Gavin.
Okay, fine. I hope Abe gets recorded.
Are we good? Yeah, what's up? Yeah, well, the reason why, what you're talking about is if you take the derivative of x to some number, right? Its derivative, if you were to take the derivative of this, what you get is the number in front, the x, and then the number minus 1. But that only works when the variable is the base. What we have is the variables in the exponent, where our base is a constant. That's why it doesn't work that way. So let's flip it over. Same directions, we're just going to find derivatives. Now, f of x has an outer function and an inner function, so we will need a chain rule. The outer function is just some base raised to a 3. So we use our exponent rule, where we bring the exponent down to the front, decrease the exponent by 1, And then we have to multiply by the derivative of the inside. But what is the derivative of e to the x minus 1? Yeah, it's just e to the x. And there's really no reason to do anything else. I mean, you could scoot the e to the x to between the 3 and the parentheses, but why? It's done. I would just call it right there. Very,
Okay.
very, very simple. Now for b, though, oh goodness, radical. Yeah, yeah, that's it. It's just this was just the chain rule. This 3, this 2 is the derivative of the outside, and this e to the x is the derivative of the inside. That's it. Before I try to tackle f of x, I'm going to write it as an exponential 2e to the negative x plus 1 raised to the negative 1/2. And then we're just going to do the exact same stuff that we did on the last one. We're going to bring the exponent down to the front. We're going to decrease the exponent by 1. And then we're going to multiply by the derivative of what's on the inside of those parentheses. Bringing this negative 1/2 down to the front. Don't touch the inside. And decrease this by 1. So it's negative 1/2 minus 1. That gives me negative 3/2. Now we have to multiply by the derivative of the inside. And the derivative of a constant is just 0. So really what we're talking about here is the derivative of 2e to the negative x. This is a double chain rule, guys. So what is the derivative of 2e to the negative x? Well,
I'm really stupid.
first thing you do is you write the exponential the way it was given to you. And then you multiply by the derivative of its exponent. So this is a double chain rule. Chain rule inside a chain rule. The reason why is because the derivative of the exponent was not 1. Anytime the derivative of an e's exponent is not 1, you have to do the chain rule.
Oh, yeah.
So again, the negative 1/2 and the negative 3/2 was the derivative of the outside. Then we had to tackle the derivative of the inside. And so you just forget that you've done stuff for a minute. You're going to talk about the derivative of this. The derivative of every exponential with an e in it is write the original e exponential and then multiply by the derivative of the exponent if that is not a 1. And the derivative of this exponent was not a 1. It was a negative 1. So that's why we have 3 different things there. This little negative 1 is a result of this one's chain rule. And this 2 sets of parentheses is a result of this one's chain rule. Got a chain inside a chain. And I am going to clean it up a little bit, specifically because when you multiply 2 negatives, you get a positive. And since this 2 does not have a negative exponent, a 2 and a 1/2 will cancel each other as well. And everything that I'm looking at here has negative exponents. This has a negative exponent, this has a negative exponent, so it's all going to end up underneath a 1. 1 over e to the x, because when you bring it to the bottom, it's going to have a positive exponent. And you know what? I don't feel like writing this as a radical. I'm just going to leave it as a 3/2 power. I don't see a reason to change that. Yes, Bria.
Wait, so sorry, I'm still like stuck on the double chain rule. Did you know that by looking at the original?
The reason why I knew it was a double chain rule is because I had, how about this? How about I use different colors? I'm going to use a different color every time I find a different function, okay? So I'm going to do this. I know I can't see it on the screen anymore, but you can on your paper, right? So f of x is, now the outside structure is its own function. There's a function that we could derive, right? We could bring this down, subtract 1. Now the inside is a function as well. Exponential plus 1, right? Exponential plus 1. But the exponent on this exponential is its own function whose derivative is not 1. So there are 3 different things going on. There will be a, let's find the derivative of the blue stuff. which involves not touching anything inside the blue parentheses. Then there'll be a find the derivative of the purple stuff, which will require us to find the derivative of the red thing because it is not a 1. Does that make better sense?
So the x is like negative 3x instead of the negative 1, you just multiply it by negative 3.
Yes. So whatever constant was in front of this x, whatever, and it didn't have to be negative. If there was any constant in front of this x, then this is going to require another chain rule where its derivative would end up happening out here.
But if it's just x, you don't need to do another one?
Right, because what's the derivative of x?
1.
1. So technically, every time you find the derivative of e to the x, you are using the chain rule. It's just that the derivative exponent was 1, so it didn't change anything. Okay? Cool. Any other questions on it? Yep, a couple of them. Courtney? Oh, yeah. So again, if it would help, I can write the original function in different colors. We had something cubed, so I had a blue part. And then, let's use green, I had an inside part. So I had to handle the blue derivative first, which is bring the 3 down and subtract a 1 from it. But I don't touch the inside when I do that. Times the green derivative. This is the green derivative right here. Because the derivative of every e to the x is e to the x, and a derivative of a constant is automatically 0. Okay? Yes? Shh, I can't hear you over him. I'm sorry. What were you saying?
On B, after we simplified it, I did k even like that x staying negative on the bottom.
The only reason why I left this negative is because this was supposed to be a radical, and I really didn't want to have a fraction inside a radical inside a fraction. It was the only reason why. I just didn't see a reason to do anything better with it. I mean, we could have tried, but it just would have gotten uglier and uglier and uglier. Again, the only reason why we ever simplify these things at all is so that we can plug a number into them. I mean, if you're not going to plug a number into it, only simplify as much as you want to. Okay?
Bet, yo.
Would it be beneficial for me to make up one that had multiple chain rules?
Yes.
Okay. Well, then let me grab a piece of scrap paper. And let's see if I can do a... But nobody's allowed to hate me. You asked for this. Okay?
I hate you.
Mm-hmm. There you go. We're going to find the derivative of that.
No. Okay, are they actually going to be that hard, though?
I don't know. I can't remember the difficulty of the homework or the test.
That's like a hard one.
Oh, no.
You did it on purpose.
Not a difficult question. If only life was full of all the easy things.
Well, yes.
So I'll tell you what we're going to do. We're actually going to manipulate this so that it's not as difficult as it looks. Does anybody see what I'm talking about or no?
I put it to the 1/2 power.
Yeah, but if this is a 1/2 power and this is a 5,
That makes it 5 power.
it's a 5/2 power. So that actually does make it a little bit easier than if you hadn't done that. There. That helps a little bit. That does help a little bit.
It actually makes it a lot better.
Yeah, and now it doesn't look like a triple chain rule. Alrighty, let's try to tackle this derivative. What do I see? Well, here's what I see. I see an outside function. Okay. I see an outside function that I'll write in blue. I see an interior function that is an exponential plus polynomial, but the exponential has an exponent that is a function. So I'm going to have to handle it like that. Because the derivative of that exponent is not 1. So that will require a chain rule. Let's let her go. F prime of x. First we do the blue derivative. I'm not going to skip any work. I've got the 4. I'm bringing down the 5/2. Not touching the inside. 2e to the 3x plus x. And subtracting 1 from 5/2. That gives me 3/2. That is the blue derivative. Comfortable with that? But since there was a function inside those blue parentheses, we must find the derivative of what's inside the functions that requires, or inside the parentheses, that requires me to find the green derivative. So times the derivative of the inside. The derivative of the inside involves an exponential and a polynomial. The derivative of every exponential is write the exponential without touching its exponent, and I will handle its chain rule in just a second. I'm still working the green derivative. The green derivative is the derivative of the inside, so it's the exponential plus 1, because that's the derivative of x. Now, when I did the derivative of the inside, it required me to talk about an exponential whose derivative, or whose exponent has a derivative that is not a 1. So lastly, times the derivative of its exponent, which is that 3. So this happened because of the red. This happened because of the green. And this happened because of the blue. Actually, I could say all of it. This is the blue, that's the green, that's the red. Does the color help? Seeing it like that? Kinda? Yeah, what's up? Well, the reason why we're not doing that, if I had just said find the derivative of 2e to the 3x plus x, then you would have spot derived, like you're saying. But the reason why we're not right now is because we're doing derivative of inside. So when you're doing the chain rule, the derivative of the inside, if it has its own chain rule, would cause you to find the derivative of its inside again. For example, and I know that just sounded really weird in words, can I scroll up? And by scroll up, I mean just push my paper up. How about this? If you had to do, and this is why, okay? Let's say you have f of g of h of x, which is essentially what we have, right? This is 3x. This is 2e to the 3x plus x. This is 4 square root of all of that crap, right? If you wanted to find the derivative of that, ddx of this, you would do it from the outside in. What you would get is the derivative of the outside without touching the inside. Counting parentheses. 1, 2, 1, 2. Okay. And then here's f like that. Right? Did I close those correctly?
Yeah.
Okay. So here's the derivative of the outside times the derivative of the inside. That's going to be g prime of, don't touch its inside, that, times the derivative of its inside. Now, if you go with me here, f prime of, don't touch any of this stuff inside, is what I underlined in blue. G prime of, don't touch anything on the inside, is what's in green, because it's the derivative of the entire inside. I treat it as one object. And then times anything else, should there have been more chain rules. Now you've made me doubt myself.
It's pretty easy.
Yeah, the 3 would also affect the
I did it on my own.
Yeah, but I think it's supposed to affect the 1 though. But again, if I had just said find the derivative of this, then it just would have been 2e to the 3x times 3 plus 1. Yeah, I think you guys are right. Yeah, I think you guys are right. I shouldn't have put that. Should have been right there. My apologies. You made me doubt myself, and I'm glad you did because I did it wrong. So sorry. Mhm. No, yeah, sorry. No, you're right. I had to. I'm glad you guys said something because I had it wrong. See, even when you're as good as me, you can still mess up. I feel like that's a good place to stop the video.
Alright, what was